This lesson is going to focus on some of the background of why reactions happen, and we'll talk about collision theory. So in order for a reaction to take place, the molecules need to interact and specifically collide with each other. Once they collide, they might react or they might not. It depends on if the collision had enough energy to break bonds and if they collided in such a way that the orientation was correct for new bonds to form. The Arrhenius equation, which we talked about, has the term A, the frequency factor. You can break the frequency factor up into those two factors. Does it have enough energy? And is the orientation correct in order to determine if the collision is effective? So an effective collision, you need to have enough energy to overcome that energy barrier, and so you need the kinetic energy. So this diagram is just trying to show that sometimes molecules collide with enough energy and sometimes they don't. And we also need the correct orientation. So you can see here, if we are colliding these two molecules together, they need to be in this orientation so the two chlorines can react with each other. But there are many ways for them to, this is the effective orientation, the two chlorines reacting. But there are lots of ways for them to collide and not have the right orientation for the reaction to take place. So now we should understand more deeply why these following things affect the rate of a reaction. The nature of the reactant, so what kind of bonds you have to break in order for the new molecule to form is going to affect the rate. If they are strong bonds that you're breaking, your rate's going to be lower. Temperature affects it because if you have a higher temperature, you have more effective or more molecules with the energy needed. And then concentration. If you have a higher concentration, you're just going to have more molecules running into each other, which is going to increase your rate.